Lesson 11.1 Maxwell's Equations and the Production of Electromagnetic Waves. James Clerk Maxwell was a Scottish physicist who showed that electricity and magnetism are the same thing and together create electromagnetic waves. He came up with 4 equations that completely combined electricity and magnetism. First one's Gauss's law. And that upside down triangle is a del symbol. It's calculus. Gradient of electric field equals a couple constants. Anyway, here's the rest of them. And you can see with Gauss's law, we have Gauss's law for magnetism, which says that there are no magnetic monopoles. We have Faraday's law, Ampere's circuit law. No, we're not using them, but there they are just for your information. Maxwell then predicted using his equations that the speed of electromagnetic waves would be 1 divided by the square root of mu0 times E0, which is the permeability of free space, and the permittivity of free space, which is 3.00 times 10 to the 8 meters per second. That one's the E0 is that, mu0 is that. When you put them together, you do in fact get C equals 3 times 10 to the 8. Heinrich Hertz was the first scientist to generate and receive electromagnetic waves, hence the unit of frequency is his name, the Hertz. Creation of electromagnetic waves. 2 wires are connected to either side of an AC generator to form an antenna. This EMF, or voltage, produced by the generator creates a potential difference between the ends of the wires. And that electric field moves off away from the wires at the speed of light. The potential difference then makes this electric field, and it moves away from the wires at the speed of light, and then it changes direction and the electric field changes direction. And then that electric field moves away from the wires at the speed of light. So here we have point P. Point P is now moved to there, to there, to there, to there as it moves away. Here it's gone down, that moves away, is now there, is now there, is now there. This point is now here and here. That one is now there. So you can see it keeps moving away. Whatever direction the electric field was pointing, it moves away at the speed of light. And you end up with this sine wave. Also, as the potential difference changes directions, the charges in the antenna run from one end to the other, creating a current. This current creates a magnetic field, and that'll be perpendicular to the wire. So the electromagnetic waves are both electric field and magnetic fields, and they are perpendicular to each other, and both are perpendicular to the direction of travel. They are transverse waves. We know that because they're going up and down, following the charges moving up and down the antenna. To detect electromagnetic waves, we need an antenna, again, that is designed to either receive the electric field or magnetic field. If you're going to receive the electric field, you need a straight antenna. The electric field will cause electrons to flow in the opposite direction of the electric field, creating a current that changes with time as the electric field changes. That current goes through some circuitry, goes to an amplifier, and then comes out as whatever. So we have circuitry, has a capacitor, an inductor, and gets amplified for your speakers, or goes to the TV circuit, or whatever it is. To detect the magnetic field, you need a loop antenna, because the magnetic field will go through the loop, which would, as it goes back and forth through the loop, it causes a changing flux through the loop, which then would induce a current as in the loop as the flux changes. Again, that goes through an LC, inductor capacitor circuit, and amplifier, which then gets sent out to the device to create your picture, sound, or whatever. Devices like your cell phone have antennas that have both straight segments and loops, so it uses both to pick up, both types of antennas to pick up the signal. All right, the electric field and magnetic field strengths are related to each other. The stronger the electric field creates a greater current, which then makes a greater magnetic field, so they are directly proportional. And it turns out that the E field divided by the B field equals the speed of light. Electromagnetic waves can travel through a vacuum or material because both electric fields and magnetic fields can exist in a vacuum and through material. All electromagnetic waves travel the same speed in a vacuum, which is 3 times 10 to the 8 meters per second. Now that's in a vacuum. If it's traveling through a material, then it will slow down. The frequency of the wave is determined by its source. So that means the wavelength is determined by the speed and the frequency together. Calculate the wavelength. Produce waves. Do your homework.